The Docker Compose Conundrum, a local development environment, fails silently, masking a critical configuration flaw. The user's attempt to launch a 3-service application proxy, app, and database via Docker Compose has resulted in a non-functional state, a common yet critical failure point in modern DevOps workflows.
This scenario, promoted under the Learn by Fixing initiative, presents a classic orchestration issue where the defined services cannot initialize or communicate as intended. The immediate symptom the application doesn't start belies a deeper investigation into service dependencies, network configuration, and health checks.
The urgency stems from the blockage of the entire development pipeline, rendering further testing, debugging, and deployment impossible until the root cause is isolated and resolved.
Decoding the silent failure. The 404 error from the scenarios webpage is a meta-indicator of a missing or misconfigured foundational component. The provided context reveals a significant disconnect, while the user post describes an active debugging scenario. The linked article content returns a 404 error, stating the page you are looking for does not exist.
This is not merely a broken link, but a symbolic parallel to the Docker failure. Both represent a service discovery or routing problem. In the Docker context, this often translates to the proxy service, likely an Nginx or Traffic instance, being unable to route requests to the upstream app service, or the app service itself failing to connect to the database.
The status quo is one of fractured connectivity where individual containers may be running, but the integrated system is not.
Anatomy of a multi-service breakdown. The failure cascade typically originates in misaligned environment variables, exposed ports, or dependency weight conditions. A deep dive into the probable mechanics reveals a chain of potential faults.
First, the database service must be fully initialized and accepting connections before the app service, which depends on it, can start successfully. This often requires implementing a robust health check or using an init container to manage startup order. Second, the app service must expose its application port correctly within the Docker network and be configured with the proper database connection string, which usually involves environment variables pointing to the database service's container name.
Finally, the proxy service must be configured with the correct upstream host. The app service's container name and port and its configuration file must be correctly mounted into the container. A failure at any of these handoff points, be it a typo in a Docker Compose,
IML volume mount, an incorrect environment variable, or a missing network alias results in the observed silent failure.
Verdict: configuration as the critical path. Resolution requires systematic validation of the Docker Compose definition, service logs, and intra-container networking. The strategic verdict is that this is a configuration and orchestration failure, not a code defect.
The next steps involve a methodical triage, examining the Docker Compose IML file for syntax errors and dependency ordering defined under the depends on key, using Docker Compose logs to inspect the startup output of each service for explicit error messages, and executing Docker Compose exec commands to test network connectivity between containers.
Can the app container ping the database container by its service name? The final assessment points to a high probability fix in aligning service definitions, but the risk remains that underlying issues with image versions or host system resource constraints could also be culprits.
The opportunity lies in mastering these diagnostic skills, which are fundamental for SRE and sysadmin roles in maintaining resilient containerized systems.